infinity for them, for the particle. This is the difference of the physics and life. So that's all. So if you give me the potential, I can give you the equation of state to you, with interaction. So you need to know the potential, and you need to also know the U. Yes. You can repeat again the calculation and find the total energy for the system with interaction. I will tell you what is the lowercase n. And take it again, I think R cubic again. Yes, what? Potential. This n we will write here. If you see n somewhere, this is just the n over v, just to make it more simple equations. Density, volume density. It could be a work for somebody if just somebody just. I think it was done before, but they are integrals, so they are improper integrals, no? Improper integrals over real range of R. So we need to know that when the integral will be converged and when they will be divergent, diverging and convergent of this integral. Not all the interactions can give you the finite value for that. I mean, if your interaction is Coulomb, and if your G is very special form, you can get finite value from here. Otherwise, it will tend to infinity. You need to have some guarantee that this integral is not infinity. If it becomes infinity, what does it mean? All the discipline will be destroyed, actually. You get PV infinity. What does it mean? So I need to pass to more mathematical, just one line, just to guarantee that you can have this integral. So to show that this integral are converging, especially the second integral, what is the difference of this and this? You see, even if I don't give you this, and I don't give you what is that, and I don't say that what is that, this integral is the partial derivative of u. So partial derivative of u is f. So this is the average of the f in some volume. So this is pressure. This is the average of u itself. Average. So average of the u itself is the total energy. So this is the total energy. So the condition is that u and partial derivative of the u, when r tends to the 0, r tends to infinity, should be less than infinity. We call it well posed or well defined. And the GR should tend to the 0 when r tends to infinity. So I will give you, because this week I will give you homework. You're going to have 1 week to think, because last couple of weeks we don't solve any question. So one of the questions will be, I will give you a type of the potential and the G, and I will ask you to calculate this integral. When you calculate the integral, you will find the equation of the state. One of the form for the equation of this. So that's the all. So that was actually the main result was I was trying to attend and reach this point. So you see that just thanks to the definition of the quantity called virial, you can get the equation of motion for the equation of a state for the interactive gas. So I want just a few minutes talk about the next chapter. So I'm talking about the chapter 3 of the Patria, or chapter 7 of the Huang, or any other books. For me, the title is important. I want to start just a little bit about the canonical system. So we just talked about the microcanonical before, and about the Liouville equation. So we are going now to talk about the canonical systems. So just the question is that in canonical system, what is the probability? What is the probability of finding an equilibrium state of the system with energy ER at temperature T? This is our main problem. You never can have a system fully isolated, because if the system is fully isolated, so I mean theoretically you can do that, but actually you cannot do that. And we are talking about the real system. So we need to think about how to make a temporally isolated system. So what does it mean? You see, this is the a universal system. Actually, this is the whole environment around that, and this is a subsystem. We call it A. Everything is related to this subsystem A. When this is I told you, this subsystem A needed to have a transfer of the energy or particle or something with the other part. So the other part, what is remaining here, we call it A prime. So A prime is reservoir. So there is some energy transportation between these two parts of the system. I will start by very abstract thing, but actually they are not very, they don't play very much important role in our discussion. So I want to, and I fix the temperature of the system at the T, so T is fixed for the whole system. I want to find, and this is, what does it mean? This is a part of this, so this is actually, it can be an ensemble. I mean, you can have a number of the hydrogen atom here, for example. N number of hydrogen atoms you have here, but we call it all as a subsystem.